By the way, students are always very shy about sticking their hand up in lecture because they're afraid they're going to say something stupid, you know, and everybody, you know, will, right? You're sort of embarrassed about what you might say. You might get the wrong answer to something. Here's the way to think about that. Suppose you have a question, or you know, you want to try out whether you have the right answer to something. You stick your hand up. What's the very worst thing that can possibly happen? Your hand goes up. I call on you. You say something incredibly stupid. I make a biting, sarcastic remark. Everybody laughs at you, and you feel like an idiot. Well, doesn't that happen every night in the dorm? You know, it's no big deal. Whereas, if you don't put your hand up and say that stupid thing, what happens is you go on thinking that stupid thing, and you flunk the course, and you drop out of school, and become a bum on Telegraph Avenue, or you know, maybe you major in philosophy or something and become a bum on Telegraph Avenue. But anyway, you don't get a job and you're miserable for the whole rest of your life. So the stupid thing is not to be wrong about something. It's to keep on being wrong about something when you have an opportunity to fix that. So if you have a question, ask it. In particular, something that students always do is they wait until the end of class, and I'm putting things away, and then they rush up to the front to ask the question that they had 20 minutes ago. There are two reasons not to do that. Number one is, after us, there's another class coming in. You can already see them crowding in the doorway up there. I have to get this stuff put away, out of the way, so that they can move in. You have to get out, you know. So it kind of slows things down if there's a big mob of people in front asking questions, and that's sort of not nice to the next class. And also because I have that on my mind, when you ask questions at the end like that, I give short, snippy, mean answers because I want to get you out of the way quickly. The second reason not to do it is that probably it's a good question, especially if it indicates a misunderstanding. Because if you don't understand something, probably a quarter to a third of the other students in this room don't understand it either. Or, even worse than that, the reason you don't understand is that I made a mistake, which does happen, you know, once every couple of years. In which case, nobody in the class understands it. And you come up and you ask the question, and I say, oh, shoot, I should have said this to everybody, and then I, you know, feel bad. So if you have a question, wave your hands in the air, ask it in lecture. Don't ask questions coming up front. Computer science is not about computers. That's electrical engineering. And it's not a science. Because you know, mostly we don't go out and do experiments like real scientists. I mean, there's some of that. There's some things that are like real science. But mostly what we do in computer science isn't like that. It's partly engineering. We do what engineers do. We go out and build things. Only what we build is all in our minds, not hardware. And it's partly art, because we try to make things that are beautiful both internally in the way they work and also externally in how users use them. So computer science is a funny name for it, but there you are. All right. Computer programming is really, really easy. Who's been programming computers since junior high school or earlier? Right? A bunch of you. That's not because you're a genius. It's because computer programming is really, really easy. Anybody can program computers, as long as the program you're writing is pretty short, right? So you can kind of keep it all in your head at the same time. What's hard is writing great big computer programs. And that's hard because you do something over here that messes up something you're doing over there, and you just can't keep track of everything. So what computer science is largely about is how to take big, complicated, messy problems and make them manageable. And our biggest weapon against complexity is something called abstraction, which means trying to get away from nuts and bolts and towards sort of big ideas about what it is you're trying to do. Everybody learned back in middle school probably that computers talk in ones and zeros, right? Everybody learned about ones and zeros. We're not doing any ones and zeros in here. And it was true what they told you about the ones and zeros, but human beings don't like to do ones and zeros. In the early days of computers, people really did that. They went up to the computer and they pushed a bunch of switches and said, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0. But we don't do that these days because we've invented abstraction, which is a way of letting you speak in a language that's closer to the problem you're trying to solve. And that's mainly what we're going to be talking about in this class.